Hello, teacher. Today our team will present about one of the most popular parts of basic electronic circuit components. It is uh, there are wires, connectors, and cables. And as you can see in this screen, there are 6 members in our team, and our team will present about 5 parts. The first is wires, and next is the connectors. Oh, sorry, the cables, and next is the connectors. And in the fourth part, we will consider about the symbols of wiring and connectors. And the fifth is the high frequency effects within wires and cables. And in the first part, we will present about why is why it is so important for us to consider. And now, Vong will present about it.
Hello everyone, I'm Vân, and we'll talk about the first session, wires. We will learn about definition, characteristics, as well as classification of wire. So to start with the definition, what is a wire? A wire is defined as a cylindrical, flexible strand or rod of metal, and it provides a low resistance pathway for electric currents. Nowadays, you know that most electrical wires are made from copper or silver, and is rotated by an insulating coating of flathead or a rubber or lacquers. And wire have some typical feature and probability, such as a wire diameter is expressed in terms of a gauge number. And in a gauge system, when a wire's diameter increase, the gauge number will decrease and the resistance also decrease. So when we want to have a lower current, we should use a smaller gauge wires. And another interesting thing about wires is if too much current is sent through a lower gauge wire, the wires could become hot more and more, even to melt. And now move to the last part, the classification. Here you can see in the picture, this is some common kinds of wire. Here, this is a 15 solid brush wire. So this wire is often referred to as half-cup wires, and is usually insulated with PVC, polyethylene, or Teflon. And this usually used for hot paper checks, referring printing, circuit board, or other application where small bare antique wires are needed. And the picture in the center here, this is a speaker wires. Speaker wire is stranded to increase surface area for circuit flow, and it has a high copper content for better conduction. And the last picture, magic wire. Magic wire is used for building codes or electromagnetic or anything that requires a low number of loops. For example, a turning element in a radio receiver. And typical wire size is about from 22 to 30 gauge. And that's all for my session. Thank you.
Hello, my name is Nguyễn Thành Luân. This is my section, a cable. So I will present the cable. About the cable. So the first one, I will talk about the definition. The cable consists of the multiple the number of independent conductive wire. So the wire within cable may be cylindrical, stranded, or some combination in between. The secondly, I will talk about. I will show you about some type of cable. The first one you see on the screen. This is the twin lead. Twin lead it have two wire. The next is the coaxial cable. Coaxial cable have one wire in the cover around by plastic. The next thing is the ribbon and flame. Next is twisted pair. Twisted pair is two wire with pair. The next is the wire and flame and strip lines. We'll talk about the kind of cable. Dual coaxial. Dual coaxial have two wire and around. The next is the shielded twin list. It have the plastic jacket around the cover around, and the next is the mental shield. In it have in insulation and conducting wire. The next we talk about balance coaxial. Balance coaxial is the cable have the copper shield to protect insulation and conductors. The last I will talk about the unbalanced coaxial. It's the same the balance coaxial, so but it just only have one conductor is the hot list. And however, currently people use the shielded twisted pair cable, which is the most popular type of cable in the world. Example is Cat5. The full name of Cat5 is the category 5 and the Cat6 or Cat5e. So it's applied in the transmit internet with the faster speed. This is the end of my section. Then I will turn for my teammate. Thank you.
Yes, my name is Nhất, and now I will continue the presentation of the part 3 connector. And at the start, I will tell you about a definition. Connector consists of plus male ended and jack female ended to join this similar connector together, and adapter can be used. And in the book, we have 26 the connector, but now I will just tell you about some common connector. And the first of uh, common connector is 100 and 117 volt. Uh, this is a typical home appliance connector. It comes in unpolar, unpolarized and polarized form. Both form may come with or without a ground wire, and and it's like this, or yeah, it's like this. Um, uh, and next, it's the banana cable. It's used for connecting single wire to electrical equipment. It is frequently used with testing equipment, and the plug is made from a four-leaf spring tip that snaps into the deck. And uh, the third is space plug and barrier strip. Space plug and space plug is a simple connector that use a screw to fasten a metal space to a terminal. And a barrier strip often acts like the receiver of the space plug. And last but not least, is the cream. The cream connector are color coded according to the wire size. They can accommodate. They are useful as quick friction type connection in DC application when connections are broken repeatedly. Uh, a crimping a crimping tool is used to fasten the wire to the connector. That's all.
Em Sơn and I will continually represent about the part wiring and connector symbols. Firstly about the wiring. Um, those symbols on your left hand side help you know about the wires in the circuit diagrams, and moreover, I want to know this in daily life. And for example, the terminals uh, in the realities, which is connecting wire with device, about the shield which is protect the circuits. Moreover, we have enclosure, shield wire, and two conductor cables. uh, the shield with two conductor, especially coaxial cable, which transmitted radio signal. As you can see um, from the antenna cable, and uh, cross conductor with no contacts. About the connectors, we have common connections, contact with push male and contact female, or or we have some push like female female or male male. Moreover, we have causal connectors, 2 plugs and 3 plugs, and in Vietnam we use two plugs more than 3 plugs. 2 plugs have tip and sleeve, while 3 plugs have another is ring. And we have 2 conductor jack and 3 conductor jacks, and from those issue we can classify them. And finally, is about the how to know which plugs and sockets are non-polarized or polarized. As you can see, non-polarized, we have to know exactly which wires are hot or natural. Polarized, we have to know exactly hot or neutral wires are non-polarized. We needn't to know about which wire hot or neutral. And in some countries they use 170 volts, while in Vietnam we just use 220 volts. And as you can see, this is the device I have in my house, from my house. And the next section is about high frequency effects within the wire and cables, and we will continue about this.
Hello, teacher. My name is Vũ Trần Quang Duy. I will present my part A, high frequency effect within wires and cables. So we come to section A, the way the behavior in wires. So it talk about AC and DC current and how electrons flow in which AC or DC current. I will show you that. Yeah. So we come first to DC current. Here we have a Y, right? And we have electron right there. Yep. And it flow like water, just only one way. Here, if we cut in this, yeah, we have a cross section like this. Is it Y and electron? Yeah, the electron like this, and we come to AC current. What we have here, right? The electron is move different about DC current. Yeah, right. But it's not only flow from and but it's also is flow back like this. Yeah, like this. And when it flow like that, it create each of electron create the magnetic field, and this magnetic field push each other electron, make it like that. Here, electron. Yep. Here, you see in the center of the Y, it doesn't have electron, but the electron is go toward to the surface of the wire. Yeah, because magnetic field of this electron, this electron. Yeah, it push every electron. One electron push this electron and so down. It doesn't have in the center. It's just on the surface of the wire. So we come back. Presence. So this phenomenon is called the skin effect. You can see it generates the magnetic field push each other. Yes. Now we have this effect that it is very important because in the high frequency, the resistance of the wire become an influential factor. You know that the resistance is make the current hard to flow. And here we have a table. Yeah, a table here. A wire goes is mean peak of the wire. Yeah, we have 22, 18, 14, 10, and we have here a frequency. Under it a resistance of each situation is a symbol. We have y equals E22 and frequency E 10 10.7. Yeah, we have a 21.7 resistance ohm. Yeah, but if the frequency increase like that, so the resistance will increase too. Here 217. Wow, that's so big, right? It's different. And if the size of the y is decrease, it means it's smaller, the resistance will increase like this. Example, in y equals 22 is the resistance in here is 217, but in the y equals 10 is increased to 873. Is also a big distance, right? Next, we come to the cables. Of course, it's likewise. The cables also have this effect too, but also that it have inductive and capacitive effect because magnetic field and electrical field in the cable. Okay, here we have two type of cables. First, is coaxial cable and two pair cable. As you can see, that the coaxial cable is just only one core in the cable, right here, and electric field is this way into the center, and the magnetic field is go out. Yeah, it's opposite. And in the pair cable, we have see that it like affect each other here. This way push it way, electron go this and go there. Two core, two wire. Okay. So we come to the impedance of the cable. Impedance of cable is called the characteristic impedance. So this symbolize Z dot, and L and C. Okay, L inductance and CE capacitance. Okay. Yes. It's a coaxial cable. It is just a formula. So we come to impedance matching. If you connect some device, have a cable to another device, like I use my headphone here. Yeah, we have the Y. Yeah, you can talk a Y or back cable, and I connect to the my laptop. So the impedance of the headphone and impedance of the laptop maybe it's different, maybe it's same. So what if it's different and what if it's same? So we can see it here. We have unmatched impedance and matched impedance. So example, my headphone have G dot and my laptop have GL, right? And if my headphone impedance, my headphone is less than impedance of the laptop, it's like the signal, like the wave, yeah, it's go from headphone to laptop, and it go like wave, and when it come to his phone, from his phone to laptop, it will rejective push. Here you can see is um, a transmitted push is smaller than rejected push in here. Yeah, so like we lost some energy when we transfer from his phone to laptop, right? So we come to another situation, E G dot greater than GL. It go like that, but it also have reject push, and the rejected push is smaller than the transmitted push. So anyway, when we have unmatched impedance, we also lost some push, right? Some energy. And here is the ideal. Here, oh sorry. Here is the ideal match impedance. It means it's from his phone to the laptop, and then laptop from to his phone. It doesn't lost anything. That's the ideal. Next, we come to standing waves. This also have a formula about the standing wave, because can you see it's related to impedance matching. You can see it. The standing wave pattern results from the interaction of forward going and reflective signal. Okay, it means it come and some signal it go back. That's so so the scientists they have found some formula to calculate this the loose energy. So this is the VRM mass and VRM mean. Yes. Here is a graph show about our signal when it's transferred from this device to another device. You can see here signal and the lambda. Okay. Next, we have a technique for matching impedance. It's like the solution to So the if you have the unmatched impedance, so here we have a match, right, in the circuit. We have here we resistance, right, G1 greater than G2. Yeah, here is transformer, right, and power system transmission line transformer. So also that techniques just have us how to resolve the unmatched impedance. Just not only that. So okay, this is the end of our presentation. Thank you for your listening.